Swayam Prabha. Digital India. Educated India.
The next concept that we have to see before going into finding what the change in length by original length is called as the gradient operator. Of a vector valued vector function. Okay. What this vector valued means is, this is the range of the function is a vector. This here says about the domain of the function. Function is a vector. Example of vector valued vector function is displacement field, which is a function of, for us, capital X comma t, where x is position vector of material particle in the reference configuration. Okay. So, that is the position vector of the material particle in the reference configuration, and this t denotes the time. U is the displacement field. This is a material representation. This is a material representation of the displacement field. Okay. So, this is an example of a vector valued vector function. Now, before going into finding the gradient of that, let us assume a function a to be a function of x and y, or let us assume z is some function of x and y. Okay. Now, what does dou f by dou x and dou f by dou y mean, or if I say, what does they mean? So, basically if I plot this function in a 3-dimensional space, with x, y and z oriented like this, I will get a surface. Okay. On this surface, I might get a surface like that. Okay. Say this is a surface on x and y axis, this is the x and y axis in the plane, this is the z axis, I get a surface like this, and what does gradient of z represent is, it represents a tangent plane to that surface. Okay. It represents the tangent plane to the surface. Just like when you have a function of a single variable, when I write y equal to function of x, and if I plot x versus y, if I get a curve like this, at any point x, the slope of the curve, slope of a tangent at that point, this angle theta is given by dou y by dou x, right. Similarly, when I have a function of two variables, there will be a surface that is formed and there will be a tangent plane to that surface. This tangent plane is characterized by two slopes, one is how this slope is and the other one is how the slope is along another mutually perpendicular direction, right. these two slopes characterizes this tangent plane. Knowing one slope in one direction will not help me find what the slope in the other direction is, because they are independent. Just like knowing the slope at a particular point in of a function will not help us find the slope at a different point. In case of a function of two variables, knowing the slope along a particular direction will not help us find what the slope on a different direction is, unless I know the slopes along two mutually perpendicular directions. Okay. So, this gradient of z, so when I say gradient of z, it means dou f by dou x Ex plus dou f by dou y Ey. If f is a function of two variables, if it is a function of three variables, will be dou f by dou z Ez. Okay. That is, there will be three. Now it is a 3-dimensional space x, y and z, and the function forms a 4th dimension, and hence what happens is this will have 3 slopes, 3 independent slopes, which I have to know before I can find what is the slope along any other direction is. Let us elaborate on this a little bit more. Now the gradient is defined as following. Let us assume that I am dealing with a scalar valued vector function, that is some phi as a function of the position vector x. Now gradient of phi dotted with a is defined as limit alpha tending to 0 phi tilde of x plus alpha a minus phi tilde of x divided by alpha. What this means is the slope of the tangent plane at x when approached through the direction A. Okay. So, what it means is in 2 dimensions, if I have this surface, there will be a tangent plane to the surface, there will be a tangent plane to that surface, okay. And if I approach the point through a direction A, what will be the slope of that line that is tangent to that point and is in the direction of A. Basically, there will be different directions will have different slopes, one direction will have this slope, one direction will have this slope, and hence different directions will have different slopes. Okay. So, that direction along which you approach is given by A. Okay. Now, let us see how this formula leads to the definition of grad phi as dou phi by dou x Ex plus dou phi by dou y Ey plus dou phi by dou z Ez. For that, let A to be Ex, then grad phi dotted with Ex would be limit alpha tending to 0 phi of x is x plus alpha Ex plus y Ey plus z Ez minus phi tilde of x Ex plus y Ey plus z Ez divided by alpha. This is nothing but dou phi by dou x. Okay. So, grad phi dot Ex is dou phi by dou x. This implies grad phi x component is dou phi by dou x. Similarly, you can show that grad phi dotted with E y is dou phi by dou y, and grad phi dotted with E z is dou phi by dou z. Hence, you get the definition of grad of phi to be this expression. Hence, you get the definition of grad of phi to be this expression. Okay. Now, we saw what a gradient of a scalar valued vector function is. Similarly, now when let us look at what is the meaning of gradient of a vector valued vector function. Okay. Vector valued vector function is u function of x comma t. Now, if I say gradient of u, what I mean is I have 3 functions which depend upon 3 variables, right. Since there are 3 functions that depends upon 3 variables, I will have 9 slopes which I have to find. For each function which is a function of 3 variables, I will have 3 slopes to be determined. Similarly, there are 3 functions, so I will have 9 slopes to be determined. So, those 9 slopes are arranged in this particular fashion. I will not go into detailed derivation of this. This is the definition of gradient of u in Cartesian coordinate system. In Cartesian coordinate system, okay, where ux, uy, uz are components of the displacement vector. To be more specific, these are the Cartesian components of the displacement vector. Okay. Same grad u in cylindrical polar coordinates would be z in cylindrical polar coordinate system. Here u r, u theta, u z are cylindrical polar components of the displacement vector, and r theta z the cylindrical polar coordinates of a point in space. Okay. So, basically we understand that gradient of a vector valued vector function has to be containing 9 components, because it is 3 functions involving 3 variables, and each of those functions will have 3 slopes, which will determine, which will make it to be 9 slopes to determine the gradient of a vector valued vector function. Okay. Now, I am not going to go into detailed derivation of how you get the components of grad u in different coordinate systems, but this will be taken as given to you. Okay.